All right, here's page 5. Okay, again, we are differentiating from first principles. So our first principles formula is you take the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. So I'm going to have the limit as h goes to 0 of 5 times, and I'm going to replace my x's with x plus h, so x plus h squared, minus 3 times x plus h plus 2. And that's the first part, that's that part, minus f of x, okay, so I could put that in parentheses, minus f of x, so that's just plain old f of x, 5x squared minus 3x plus 2, all divided by h. So then I'm going to multiply that out, and x plus h squared is going to give me x squared plus 2xh plus h squared. And we'll distribute the 3, negative 3x minus 3h plus 2. I'm going to go ahead and distribute this negative sign, minus 5x squared plus 3x minus 2, all divided by h. So again, the limit as h approaches 0, and distribute this. I get 5x squared plus 10xh plus 5h squared minus 3x minus 3h plus 2 minus 5x squared plus 3x minus 2, all divided by h. Now I'm ready to get rid of stuff that's repeating. 5x squared minus 5x squared cancels out. I'm going to keep the 10xh by the looks of it. 5h squared, I'm going to keep that. Minus 3x plus 3x equals 0. Minus 3h, I'm going to keep that. Plus 2 minus 2. So now I have the limit as h goes to 0 of 10xh plus 5h squared minus 3h, that's it, all divided by h. I'm going to factorize the numerator, bring out the h, 10x plus 5h minus 3, all divided by h. Now I can reduce my h's, so h over h is just 1. So I have the limit as h approaches 0 of 10x plus 5h minus 3. I'm going to change the h to a 0 now, so I'm going to take my limit, I'm going to let h equal 0. So I get 10x plus 5 times 0 minus 3, which gives me 10x minus 3. And from what we know about the shortcuts for doing derivatives, 2 times 5 is 10, so 10x. And then bring down my exponent of 1, I get left with negative 3. So from our shortcuts, we can double check that we got it right. Yes, we did. All right, so I told you can skip the next one because it's the same process, just harder because it's got an x cubed in it. So you can use Pascal's triangle to help you expand that, or you can multiply it all out by hand, but whichever, it's a pain. So I decided to skip it. If you want to do it, go for it. You know what the answer should be. The answer should be 3 times 2 is 6, x squared. So when you do it, if you do it correctly, you should get 6x squared. All right, but you don't have to do it because I think we have the idea here. All right, evaluate each limit. So I gave you a picture this time. So you need to be careful about whether you're approaching from the left or the right. And unfortunately, I do not have my glasses on. That was clever of me. All right, so it looks like it's saying the limit as x approaches negative 5. And I can't tell if it has anything. So we have to look from both sides. So as I approach negative 5 from both sides, here's my negative 5. As I approach it from both sides, they both go to positive infinity. So we could say it goes to positive infinity. But we could also say it does not exist because infinity is not really a number. It's more of a concept. There is no speed limit if the speed limit is infinity. So the limit does not exist. Okay, what happens is x goes to negative infinity. So if I go negative and I keep going negative and negative, I've got this asymptote here, so I do have a limit. I'm never going to reach this line right here. I'm never going to get to 3. So for this one, the answer is 3, because I'm going to get closer and closer, but I'm never going to hit it. Right, next one. As x goes to positive infinity, so if I go this way and this way, it does not look like I have an asymptote. So this is going to go to positive infinity, which means that there really is no limit. The next one, I have -3 from the left. So here's -3, but I want to come at it from the left. The little minus sign up here, where the exponent would go, that means from the left. So from the left, I am approaching -3. So that one's -3. Now I want to approach it from the right. So I'm also approaching -3, but this time from the right. This is approaching 2. So notice it's approaching 2 different numbers. So that means that there is actually no limit at x equals -3 because I'm approaching 2 different numbers. So we could say, okay, it's approaching 2 and it's approaching -3. That means the limit does not exist because it's approaching 2 different numbers. Okay, -1. As we approach -1 from the left, so here's -1. As I approach -1 from the left, I am approaching 6. Same thing, -1, but this time from the right. As I approach -1 from the right, I am approaching 6. And as I approach -1 from both sides, notice they're both converging at 6. We're converging to the same number, so that does have a limit. And as x approaches 4, so notice it doesn't say plus or minus, so that means from both sides. Both sides are approaching the same value, which would be -5. Now some people would say, but it never actually touches -5. We don't care. We only care about what it's getting close to. The fact that there's an open circle there doesn't matter. It's what is it approaching. We only care about what is it really close to it. Really close to it. What is it approaching? It's approaching -5. Oops, there you go. All right, so that was page 5.